To solve for the definite integral, we use the fundamental theorem of calculus, or FTC, which says that if f of x is continuous on the closed interval ab, and f of x is an antiderivative of f of x on the closed interval ab, then the integral of f of x dx from a to b is equal to f of b minus f of a. We denote the difference f of b minus f of a by f of x from a to b. This quantity is what we called the definite integral of f of x from a to b. The letters a and b are the lower and upper limits of the integral. So we read this as integral of f of x dx from a to b, where a is the lower limit and b is the upper limit. The fundamental theorem of calculus, or FTC, tells us that to evaluate the definite integral, we just need to find an antiderivative of the integrand and find the difference of its values on the bounds or limits of integration. To evaluate a definite integral, we can first find the indefinite integral and then use the fundamental theorem of calculus, or FTC. Here are some properties of the definite integrals. Number 1, if the upper limit becomes the lower limit and the lower limit becomes the upper limit, we place negative sign before the integral and switch back the value of the upper and the lower limit. Second, if the value of the lower limit and the upper limit is the same, then the definite integral is 0. Third, the integral of c dx from a to b is equal to c times the value of b minus a, where c is constant and b is the upper limit and a is the lower limit. Fourth, the integral of f of x plus and minus g of x dx from a to b is equal to the integral of f of x dx from a to b plus and minus the integral of g of x dx from a to b. Fifth, the integral of c f of x dx from a to b is equal to c times the integral of f of x dx from a to b, where c is constant. For the definite integral of an even function, we have the integral of f of x dx from negative a to a is equal to 2 times the integral of f of x dx from 0 to a. Then, the definite integral of an odd function is equal to the integral of f of x dx from negative a to a is 0. Let us find the definite integral of 4x dx from 1 to 2. Since our upper limit is greater than the lower limit, and we have a constant 4 and a function x, apply theorem number 5. But remember, to evaluate a definite integral, we need to find the indefinite integral first and then use the fundamental theorem of calculus. So we need to solve for the indefinite integral first. So find the integral of 4x dx, and this is equal to, take the constant 4 out of the integral and find the integral of x dx. And this is equal to 4 times x raised to n plus 1, so 2 divided by 2 plus c. By applying power rule, x raised to n plus 1 over n plus 1 plus c. Simplify, 4 divided 2 is 2, copy x squared plus c. The constant of integration doesn't matter when we are evaluating the definite integral, so we can omit the plus c in our solution and just copy 2x squared and then apply the fundamental theorem of calculus. So we have f of x, which is 2x squared, from a to b. So our a is 1 and our b is 2. then this is equal to f of b minus f of a. This means that we need to replace x with the value of b and the value of a, then subtract them. So we have replace x with the value of b first. So 2 times our b is 2 raised to 2 minus replace now x with the value of a, which is 1. Then simplify. 2 raised to 2 is 4 times 2 is 8 minus 1 raised to 2 is 1 times 2 is 2. And this is equal to 8 minus 2 is 6. And that's the definite integral of 4x dx from 1 to 2. As we can see, the definite integral has a unique solution or unique value. Unlike in the indefinite integral, wherein there are infinitely many solutions that differ only from one another by the constant. That is why we write plus c to mean an arbitrary constant. Definite integral has a unique solution. For number 2, since our upper limit is also greater than the lower limit and we have 3x squared plus 4x times dx, we apply theorem number 4. But first, we need to solve for the indefinite integral. So to solve for the indefinite integral of 3x squared plus 4x times dx, we need to integrate each term separately. So the integral of 3x squared dx plus integral of 4x dx. Then, take the constants out of the integrals. So we have 3 times the integral of x squared dx plus 4 times the integral of x dx. Then, apply power rule. X raised to n plus 1 over n plus 1 plus c. So we copy 3 times x raised to 2 plus 1 is 3 all over 2 plus 1 is 3. Plus copy 4 times x, our n is 1. 1 plus 1 is 2 all over 2, then plus c. Simplify, we cross out 3, we're left with x cubed plus 4 divided 2 is 2, then copy x squared, then plus c. So the indefinite integral of 3x squared plus 4x times dx is equal to x cubed plus 2x squared plus c. So we just copy x cubed plus 2x squared. Then apply the fundamental theorem of calculus. You copy the value of b and a. Then apply f of b minus f of a. So we first replace x with the value of b, which is 3. So we have replace x with the value of b. So 2 or 3 raised to 3 plus 2 times 3 raised to 2. Then minus, replace now x with the value of a, which is 2. So 2 raised to 3 plus 2 times 2 raised to 2. Then simplify. 3 raised to 3 is 27 plus 3 raised to 2 is 9 times 2, 18 minus 2 raised to 3 is 8 plus 2 raised to 2 is 4 times 2 is 8. So 27 plus 18 is 45 minus 8 plus 8, 16. So 45 minus 16 is equal to 29. So the definite integral of 3x squared plus 4x times dx from 2 to 3 is 29. For problem number 3, since the value of the upper limit and the lower limit is the same, we apply theorem number 2. The integral of f of x dx from a to a is equal to 0. Therefore, the definite integral of number 3 is equal to 0. For number 4, since the upper limit is less than the lower limit, we apply theorem number 1. We must place negative sign before the integral, so negative times the integral, then switch the value of a and b, so we have 3 and 1, then copy 3x squared minus 2 times dx. Then solve for the indefinite integral. So the integral of 3x squared minus 2 times dx is equal to, we first integrate each term separately, so integral of 3x squared dx minus integral of 2 dx equals, take the constants out of the integrals, so 3 times the integral of x squared dx minus 2 times the integral of dx. Then apply power rule to integrate x squared dx, so 3 times x raised to n plus 1, so 2 plus 1 is 3, divide 2 plus 1 is 3, minus, we copy 2, times the integral of dx, which is x, then plus c. We cross out 3, we're left with x cubed minus 2x plus c. So the integral of 3x squared minus 2 times dx is equal to x cubed minus 2x plus c. However, we just need to copy x cubed minus 2x. And this is now equal to, do not forget the negative sign. We copy x cubed minus 2x, then apply the fundamental theorem of calculus. Our b is 3 and our a is 1. And this is equal to f of b minus f of a. Do not forget the sign. You first replace x with the value of b. So 3 raised to 3 minus 2 times 3 minus, replace x with the value of a. So 1 raised to 3 minus 2 times 1. Then simplify. Do not forget the negative sign. 3 raised to 3 is 27 minus 2 times 3 is 6 minus 1 raised to 3 is 1 minus 2 times 1 is 2. Do not forget to enclose them in bracket because we need to distribute the negative sign. And this is equal to negative times 27 minus 6 is 21 minus 1 minus 2 is negative 1 times negative, so this will become positive 1. Again, 1 minus 2 is negative 1. Since we have minus sign, so negative times negative is positive 1. So this will become negative 21 plus 1 is 22. So the definite integral of 3x squared minus 2 times dx from 3 to 1 is negative 22.